Oh. Hey, how are you?
Do you guys feel like analyzing the physics behind soccer, especially the curveball?
Yeah, I heard a lot of physics revolves around kicking a soccer ball. Get the joke?
This guy thinks he's funny. We're trying to analyze something serious. Stupid joke. Well, anyway, yeah, there's a lot of physics, properties going into this. You gotta find the torque of the ball, the Magnus effect. You gotta go angular momentum, a lot of stuff, a lot of physics that goes into this curve shot.
Oh, hi. Like what they said, there's many equations that we need to research.
Yeah, that guy's not right.
Well, that guy's shaking. Look at him.
Forget those guys. This is what we're gonna do. We're gonna get the ball, kick it with a certain spin, with a curve, one of my special qualities. Then we're gonna measure the distance between the ball and the goal, then get the velocity of the ball at the initial velocity when it is kicked, the acceleration in the air, the length of my leg, and different qualities to get us into the results. It's just simple physics.
Do this.
Maybe someone else should kick.
Honestly, that was really bad. Horrible.
I'll kick it.
Alright.
Yeah.
Funky, yeah!
Let's take a look at the Magnus effect. Here we see that Rodolfo gives a little spin on the ball. Let's look at this more closely. Air is going against the ball's direction which causes a thin layer around the ball. Air coming through the left flows with the air of the curve, and the air on the right can continue, causing the ball to curve.
After our trials were performed, the following results were given. The average velocity of the ball in all the trials was 10.7 meters over seconds. After that, we found the torque, which was 1.78 newtons over meters. Then after that, we proceeded to find the momentum of the ball by multiplying the mass of the ball times the velocity, giving us 4.86 kilogram meters over second. After that, we were introduced to the drag formula being 1/2 times fluid density times relative velocity squared times the drag coefficient times transversal area. We found that the fluid density of the air was 1.225 kilograms over meter cube, and the transversal area of the ball was 1.45. So we multiplied all of that into the equation, and it gave us the drag force being 32.5 newtons. However, we had to find the surface area of the ball by multiplying 4 times pi times 1.115, which is the radius of the ball. That gave us the 1.45. After that, we went on to find inertia, which is 1/2 times the mass, which is 0.454, times the radius, 0.115 squared. And that gave us 0.003 kilograms over meter squared. With this information, we came to the conclusion that torque in the ball increases as you get farther away from the goal. Therefore, curve shots are more effective to curve even more if you're farther away from the goal. If you shoot a curved shot very close to the goal, it will not allow your ball to fully access its entire spin.
Little fun fact, David Beckham's curved kick is 3 times faster than Rodolfo's.
On the goalkeeper side, curls it perfectly, gets it up and down with pace. It starts at the goalkeeper, dips and curls towards that.